The Christmas Tree Part 1. This one is a long one, so in our first part we will just go over setting up this problem. A Christmas tree is supported by a wire that is 1 foot longer than the height of the tree. The wire is anchored at a point whose distance from the base of the tree is 49 feet shorter than the height of the tree. What is the height of the tree? Okay, there's a lot going on there. In this case, the first thing I would do is simply draw a picture to try to figure out what's going on. So they've given us that there is a tree. So let's draw a tree. Okay, we've got our tree, and it is supported by a wire. And that wire is anchored a distance from the base of the tree. The base means the bottom, and it's away from the tree. So here's my wire anchored in the ground, is connected directly at the very top of the tree. That is because they're talking about the height of the tree. So that's an assumption for us right there. So now it's a distance from the ground. I'm just going to draw the ground here. And we now have some information. In Module 13, you learned right triangles, and we're looking at one right here. We have a formula for that called the Pythagorean theorem, and the Pythagorean theorem addresses the sides of a right triangle. So now I'm going to draw one without the tree and all the other stuff in there. The right angle, the one that's like a corner, a floor running into a wall, that is your right angle, and opposite it is called the hypotenuse. Alright, so our Pythagorean theorem is one of the legs plus the other leg of the triangle equals the hypotenuse. The hypotenuse is always C. So one leg squared plus the other leg squared equals the hypotenuse squared. That means in our triangle, this is C. A and B are interchangeable, so I'm just going to randomly decide to make that side A and this side B. Again, the one that matters is you need to know which one the hypotenuse is. Once you figure that out, you can put A and B in either spot. So this is what we have. Now let's go back and see what other information we are given. A Christmas tree is supported by a wire that is 1 foot longer than the height. So here's the wire. That is our height plus 1. And that height is the height of the tree. The wire is anchored at a point whose distance from the base of the tree is, they're going to tell us another thing, 49 feet shorter than the height. So bottom of the tree, distance from the bottom of the tree, that's the side they're talking about now. And that is 49 feet shorter than the height. So height minus 49. Well, the other thing they keep talking about is the height. So that means this is the height of the tree. Alright, so if I'm mirroring this with my triangle over here, then I am saying A is height, C is height plus 1, and B is height minus 49. I am going to remember those three things and write my formula down along with those on my next page. A squared plus B squared equals C squared. We know that our A is height, our B is, that was height minus 49, and our C was height plus 1. take my formula, anywhere there's letters that I will be replacing with a different value, I put empty parentheses. Make sure that power goes on the outside of the parentheses. It will change the value if you don't do it that way. So this one's A, which is H. B was H minus 49. And C was H plus 1. So the setup for this equation is H squared plus H minus 49, that quantity squared, equals H plus 1 quantity squared.